Hello everybody. We are going to solve the second problem from the book Problems in General Physics by I.E.Irodov. Now let's jump right to it. The problem, I've copied it here. It's a point, there's a point which traversed half the distance with a velocity v0, and the remaining part of the distance was covered with velocity v1 for half the time and velocity v2 for the other half of the time. Find the mean velocity of the point averaged over the whole time of motion. Now let us look at what mean velocity actually means. So the mean velocity, which we need to calculate in this problem, is equal to the total distance covered divided by total time taken to cover this distance. Now, one thing to note here is that we have to assume that the particle is moving in a straight line. So, because the way it has been described, the velocity, although they have used the term velocity, they've used it more like speed, because we have not given any reference to the direction in which the particle is moving. And that's why I have used distance and velocity is very loosely here. So we can, for all practical purposes, consider velocity to be more like speed here, which without any reference to the direction. So it's more like moving in a straight line. So mean velocity is the total distance the particle covers divided by the total time it takes to cover the distance. So now let's look at the problem again and try to draw a diagram for it. So the point traversed half the distance with a velocity v0, and for the remaining half of the distance it covered it with a velocity v1 for half the time and velocity v2 for the other half of the time. So let us assume that the particle moved from a point A to a point B. This is the total distance the particle moves, and let us assume that this distance is twice of d. We are told that for half the distance, the particle moved with a velocity v0. So let us assume that C is at a midpoint. So the distance between A and C is d, which is half the total distance the particle moved. The velocity over this distance was v0. And let us assume that the particle covered this distance in time t1. So now we know that the distance from C to B is also d, but we don't know the time or the velocity for this entire distance, but we do know that the object covered half of the time which took to move from C to B. Half of that time was the particle moved at velocity v1, and the remaining half of that time it moved at v2. Suppose it took a total time of twice t2 to move from C to B. So for half that time, that is t2, the particle moved with a velocity v1, and for the remaining half of the time, that is t2 again, it moved with a velocity v2. We don't exactly know at this point in terms of d what is the distance it covered in the time intervals, the first t2 and the second t2, and moved with different velocities. So now let us try to write some equations. So let's look at the first part of this journey, which is the movement from A to C. The total distance covered in this journey was d, and the distance, as we know, is equal to speed multiplied by time. So speed is v0 multiplied by t1. So let's call this our equation 1. Let's look at the second part of the journey, which is the journey from C to B. The total distance covered is d again, and it is equal to the two parts of this journey, which is the distance covered in the first time interval t2 and the second time interval t2 is the other part. So distance covered in the first time interval t2 is v1 t2, and the distance covered in the second time interval t2 is v2 t2. So this is our equation number 2. Now if you look at equation 1 and equation 2, we see that the left hand sides are the same, so we can equate the right hand sides. So let's do that. v0 t1 is equal to v1 t2 plus v2 t2. So can we calculate T1 in terms of T2 from this equation? Yes, we can. So this implies that T1 is equal to, we can take T2 out, so and put a bracket there. So T2 multiplied by V1 plus V2 divided by V0. So now we know T1 in terms of T2. Now let us try to calculate the total distance, the total distance divided by total time, which is the mean velocity. Let us go back to that. So the mean velocity, let's call it V bar, would be equal to the total distance covered, which is twice of d in this case for the entire journey, divided by the total time taken. What is the total time taken? It is T1 plus twice of T2. Now we do know, so we can convert d also in terms of the other variables. So we can use equation number one where we know that d is equal to V0 or V0 T1. So let us use that, and we can write this as twice of V0 T1 divided by T1 plus twice of T2. Now we can use this particular relationship where we have found T1 in terms of T2, and we substitute that here, so that we have the entire RHS of this equation in terms of T2. So let us try to do that. So this here will be equal to twice of V0, and T1, as we know, is T2 times V1 plus V2 divided by V0 divided by T1 at the denominator. This T1 in the denominator, we're going to again write that in terms of T2, which is in terms of T2. So that becomes T2 times V1 plus V2 divided by V0 plus twice of T2. Now we can find in this entire expression that T2 is common. So we're going to cancel that in the numerator and denominator, this, and this. So and we're going to simplify this a bit. So we get twice of V0 times V1 plus V2 divided by V0. This whole thing divided by V1 plus V2 plus twice of V0. This also divided by V0. So there's a fraction in the numerator, there's a fraction in the denominator. We can cancel V0 here and here. So what we get finally is equal to twice of V0, V1 plus V2 divided by V1 plus V2 plus twice of V0. This let me save some space here. Twice of V0, which is our answer to this problem. I hope you have understood this. Please let me know if you have any questions, and I'll try to get back to you with some clarifications wherever you get stuck. So I hope this helps, and please try more problems, and keep learning physics, keep enjoying physics. Thanks a lot.